So these were all rational exponent problems. Let's do some where we're simplifying radicals. What I want you to start to think about, especially for A and B, is that a radical can be written back as a fractional exponent. So the fifth root of x to the 10th is the same thing as x to the 10 fifths. 10 fifths reduces down to 2x squared. So typically, if they give you a radical, you write a radical back. Since we couldn't write this as a radical anymore, we're done. In B, we're going to go from a radical to a fraction and then back to a radical. It's going to be great times. All right. So B, this will be x to the 8th, y to the 20th, raised to what power? 1 over 12. But now we have a product to a power. So each term of that product, oh, that wasn't supposed to be that big. Each term of that product receives that power. And now we have a power to a power. What do we do with the powers? Multiply. 8 times the 12th is 8 twelfths, which we'll reduce in a second. 20 times 1 12th is 20 twelfths, which we'll also reduce in a second. How does 8 twelfths reduce? 2/3. 20 twelfths? 5/3. And by the way, there is a shortcut going on that I can show you, but we have to do this very long way first. Now, we're going to go backwards. Notice both exponents have a denominator of 3. So I can rewrite this as x squared y to the 5th to the 1/3 power. So now I used number 3 in reverse. Rule number 3 in reverse. And since it's a 1/3 power, I can write that back as a radical as the cube root of x squared y to the 5th. Then quantity squared. Correct. Yeah. But let's look at the original problem. 12, 8, 20. What number do they all have in common? 4. If you divided them all by 4, what do you get? Oh. Cube root of x squared y to the 5th. So you could go from here to here, wait for it, in one step. But you have to have a common LCD throughout all the numbers. So if you had 12, 8, 25. All right. This is a product in here. So let's break up a radical, because a radical is an exponent. And you can break up an exponent if there's a product or a quotient. The first part of it isn't too bad. What is the square root of 4x squared? 2x. Now, even though the directions say simplify, I should have in there assume variables, blah, blah, blah. We're going to assume the variables are positive, so we don't need absolute values here. So if on a test I forget to write it, please call me out on it and be like, Mike, you forgot to write this, and I'll let you know. Now the second half, we're going to take our time with it, but remember, a square root is what kind of power? A square root is a 1/2 power. So I'm using color here on purpose. The green one is for the outermost square root. The blue one is for the innermost square root. Well, notice we have a power to a power. What do you do with those powers? Multiply them. What is 1/2 times a half? No. 1/4. A 1/4 power is what type of radical? A 4th root. How do I write the 4th root? Do I put it over the 2xy? Just over the y. What would you have to see visually to know to put it over the 2, the x, and the y? Parentheses. But since the y only is being raised to the 1/4 power, then only that goes underneath the radical.